Hello everyone and welcome back to Schoolosophy. So today we are going to speak about similarities, which is a topic in maths. So let's start. Here I have two triangles. Now as you can see, there is a line on this side of this triangle and the same line is there on this side of the triangle, which means that these two sides are equal. The same thing happens for this side and this side with the other triangle. Now because all three sides are equal, we say that the two triangles are congruent. Now two shapes are not only congruent when the length of the sides are equal. There are other cases also when the two shapes are said to be congruent. For example, when all angles are equal. So for example, here this angle is 60 degrees, this is 80 degrees and this is 40 degrees. And the same angles are repeated for this triangle, that is 60, 80 and 40. Then also we say that the two triangles are congruent. So these two triangles or these two shapes are congruent to each other. So here we have two more triangles. So now let's see if they are similar or not. One very important thing is that they might sometimes flip the shapes, turn the shapes or anything, but that doesn't mean that the shapes do not remain similar. So for example, here one of the angle of the left hand side triangle is 30 degrees and that same angle is 30 degrees in the right hand side triangle. There is a right angle here, a right angle there, and the third angle remains 60 degrees. As for the sides, it is important to notice which sides are we talking about. For example, the side opposite the right angle should be the same for even the triangle on the right hand side. Just because the triangle was flipped doesn't mean that the side changes. So the side opposite the right angle is marked in red on both the sides. Same goes for the other two sides. The two sides adjacent to the right angle should remain the same this way also. Just because it is flipped or turned, the sides do not change. And this is important for any other shape that might come, because many of the times the shapes are twisted, flipped and turned to confuse us. But we need to remember that we need to see the position of the sides and then conclude whether it is similar or not. To calculate similarities, we need to understand certain things. Because the shapes are similar, their sides are in a particular ratio. This means that their areas and volumes, the volumes of 3D shapes, will also be in a particular ratio. To understand this ratio, we need to use the proportionality constant, which is K. We need to remember certain rules before we begin understanding the proportionality constant or K. When talking about sides, we simply multiply using K. When talking about area, we need to remember to do K square. When talking about volume, we need to remember to do K cube. Now to remember this, you can use this example. For the area of a square, you do side square. Same way, you need to do K square. For the volume of a cube, you do side cube. Same way, you need to do K cube. So now here I have two triangles which are similar. The length of the side of one of the sides of the first triangle is 6 and the second side is 4. And for the second triangle, we have one side as x and the second side as 2. So if you want to find out the k, that is the factor of enlargement, we need to remember to do the larger upon smaller. So to find k, we will do this 4 upon this 2. That is, this side is similar to this side. So there has to be a ratio between this and this side. Therefore, what we will do is we will do 4 upon 2 and we will get the value as k is equal to 2. Now to find out the value of x, we can have two ways. Either you multiply this, you divide this 6 by 2 or the k to find out the value of x as 2, or you can use this. 4 upon 2 is equal to 6 upon x. Now because 4 is the side from the larger triangle, even here we will take the side of the larger triangle. That is, if larger upon smaller or the factor of enlargement is 4 upon 2, that is 2, then 6 upon x will also be equal to 2 and x will be equal to 6 upon 2, which is equal to 3. Or the other way is 4 upon 2 is equal to 6 upon x and then we cross multiply. 4x is equal to 12, so x is equal to 3. So here we have one question. If the area of the largest square is 4 cm square and the scale factor of enlargement is 2, find the area of a smaller square. So here we use the application of the formula, that is area of the large square is equal to area of the small square into k square. Now here they have given us the scale factor of enlargement or the k, which is 2. So area of the large square will be equal to area of the small square into the k square. So 4 is equal to x, that is the area of the small, into 2 square, that is k square. X is equal to 4 upon 4, and so x is equal to 1. That is the area of this small square is equal to 1 centimeter square. So here we have another question. The volume of the small cube is 7 centimeter cube. Find the volume of the larger cube if k is equal to 3. So in the previous one, we had to find out the area, and that's why we did k square. But here it's about volume, and that's why we do k cube. So volume of the large one is equal to volume of the smaller cube into k cube. That is the volume of the large x is equal to 7, that's the volume of the small cube, into k cube, that is 3 cube, which is equal to 7 into 27. And so the volume of the larger cube is equal to 189 centimeter cube. So this way we use the similarities and the proportionality constant or k to solve many of the sums of our daily lives. That's it for this video. I hope you understood. If you have any doubts, please put it in the comments down below. And if you want me to post a video on any topic, please put it in the comments below. Also, do let me know how do you like such kind of videos and should I continue to make these.